This is the second open-ended lab or the team lab. And in this lab, you will look at the common source NMOS amplifier frequency response. And basically, there are two capacitors here in this circuit. And in the Prelab number 1, you will simply derive the expressions for the corner frequencies. You will ignore the transistor parasitic capacitances because CL dominates those little capacitances. So using the techniques you learn in this class, you should be able to do the derivations. And then, of course, you will use a drawing software to include the small signal equivalent and type your formulas. The second part is about designing the amplifier. So we will figure out the resistors R1 and R2. The only criteria is that we have to have the VDS bias at the middle point, which is 2.5 volts. So using this DC sweep in multisim, you will first figure what should be the value here at the gate. That would give you a 2.5 volt DC on the output. So you will use this little circuitry using a DC sweep. Once you figure the gate voltage, then you will refer to the earlier circuit. Simple voltage division will give you the value. So you're going to pick R1 and R2 based on the components that you have, and the criteria is that the values shouldn't be less than a kiloohms. So in other words, the input resistance is limited to 500 ohms. So you shouldn't have anything less than a kiloohm, most likely, so that input resistance remains large. So pretty much there are multiple solutions. You can use maybe 12K and 8K. I don't know, these are just values, but anything any solution is fine as long as Ri is less than 500 ohms, and it gives me the gate voltage here that you determined, and I don't know what the value would be, but it should be definitely greater than the threshold. Now, as for the transistor, the threshold is around 1.9 volts. In multisim, we don't have the exact ZVN 2110 transistor, so you will need to use its equivalent. But the threshold is different, so you go to the edit model card and then change the VTO value to this. For convenience, I have actually included this transistor schematics. So you could directly copy into your schematic environment, because I noticed that multisim 14 Pseudotune edition may not even have this transistor, but the earlier versions does. So in any case, I have included the schematics, so you could just copy paste. And then once you find R1 and R2, the next task would be to verify if the amplifier works as an amplifier. So in that case, you put a small signal or a small AC signal at the input, and then you should kind of give me the waveforms showing I got this much gain. You need to report on the gain. So if you're getting something less than 1, obviously something is wrong. So it has to be a lot greater, maybe 5, maybe 8, I'm not sure, but it has to be more greater than 1. And then we will, once we get this thing working, then we will find the value of the capacitors based on the corner frequency given to us. So we're designing these capacitors based on our need. And these frequencies are given in such a way that you should be able to use the components in your kit, and you should be able to do that using only few components, maybe just 2 capacitors in parallel or 2 resistors in series at most in order to get these values. So actually, these resistors that you determine will determine the amount of capacitance. For CL, RD is given to you already, so you can easily find that without any problem. So we're doing this in multi-sim, and then finally we're gonna do this in analog discovery. And we got transistor terminals. We're gonna pay attention before placing on the board. This is very crucial. And make sure you connect 1- and 2- channels to ground to cancel any noise. And using the network analyzer tool analog discovery, you can now obtain the body plot and figure out the corner frequencies and the maximum gain. So you're gonna compare this to the multi-sim results and hand calculation results. And remember, once you figure the corner frequency, the capacitors, then you need to get the multi-sim plot, the body plot, which gives you the corner frequencies. And there's gonna be 3 persons in your group, so you have to divide this as fair as possible. And this is a team effort, so I want you to equally distribute as much as possible. So we have 3 persons, and as a suggestion I have provided the following. So the first member can do the corner frequency formulation and then use the multi-sim to design R1 and R2, and then answers the post-lab question. The second member calculates the gain and performs multi-sim gain simulation, then designs the capacitor for corner frequencies and obtain the frequency plots in multi-sim. And the third member simply does the analog discovery and then obtains the plot, the body plot. The third person would be also responsible comparing results to hand simulation and simulation results. All members should be responsible putting the lab report together. And now the third person here should be the one doing the multi-sim in the previous lab, so they have all equal contribution.